Hi guys, last time we left off we were pretty well set to mount the new power booster, but we needed to test how much current we could actually put through the system. And I didn't have a good way of thinking that. So this video is me going through the thought processes of how I should test that. But importantly, one of the things that I realised while I was doing that was that I had neglected the safety aspects of what I was doing. So I could have just not said anything, but I thought it was a good experience that that I did need to share. It's so easy to be complacent about this. We were with this system. It's a 12-volt system, and constantly in the back of your head, it's all safe. That you can touch anywhere. 12 volts is never going to be a problem. But remembering the point of the exercise is to actually boost that low voltage up to a high voltage. During the testing phase, when I was testing how much current we could get through there, I realised at one point, and you'll actually see where it happens, that I was doing some really stupid things. You must respect the high voltage side of this device. It's easy to get in the mindset of everything's safe, but there is definitely a high voltage side. And at one point, I was doing some things I really shouldn't have been doing, and I thought that you might get some benefit and learn some things. Just think about things while you're doing these DIY projects, just to make your life a little safer, perhaps. Now, I didn't have any incidents or anything, but I thought about it while I was doing it. I'm going, wait, this is really not safe. I should be being much more careful than I was. Okay, so the video is me going through the process of testing the process, and we actually got to the end without any trouble, and proved everything was working how we expected. So it's a good outcome, but I think you might enjoy me going down the wrong path and saying some stupid things. Also, I do apologise continuously. I mix my terms up all the time. People who know me laugh when I do, but I constantly saying amps when I mean volts, and volts when I mean amps, and more importantly, watts when I mean current or something. So do bear with me there. I try to correct myself, but every other word comes out as sorry. So I do apologise for that in advance. So I hope you enjoy it, and we'll see you at the end. Now, one last thing we need to do, and I'm still trying to work out how to do this. I'm trying to get a decent load, a 450 watt load, or I think I need about 18 ohms resistor. Now, unfortunately, this is like 1 ohm or something like that, so that would be drawing a huge amount of current. We don't want that. And I bought these two 12 volt heavy duty resistors. Well, I call them heavy duty, but they're actually only, if we look at the thing, they're 21 watts, so we'd only get 42 watts of power drawn. And I'm not sure what that'll do in terms of our experiment. We might well need to I think that'll be a start. I'm going to give it a go a bit later, and see what kind of see if we can get that constant current set on the booster. But again, so this would draw way too much. It's like a kilowatt of power, which we don't want to go through here, and these are only 60. So I need about 18 ohms of resistance, and these ones just are too big. So they're 8 ohms. So I need about, snap these in half. No, do you need 4 more of them? How many? I don't know. So if they're 8 ohms, if we add them in parallel, that should give us 16 ohms. So somebody's maths off, probably mine, I would imagine. Okay, problem number 1 appears to this resistors go
wiring is dodgy. That does not appear to be a good connection just there. So I doubt this is the correct. I think we'll get an infinite resistance on here. Let me just check 1 second. Okay, so we are connected up and at 4.7172 mega ohms. I'm pretty sure we aren't going to get our 8 ohms that we suspected. I'll try the other resistor. Okay, and we've got the other one on, and true to form 8.7 ohms, so as described. So I'll have to fix that wiring, and we'll get on to the next part. Okie dokie, so here's my plan here. Since we need a 17 ohm resistor to get our 450 watts, so 90 volts, 450 watts, so V equals IR, rearrange, come up with 17 ohms. So if we've got 8 and a bit, you would expect, and connecting these in parallel, we should then get effectively our 17 ohms that we need. And of course, probably my maths wasn't off before, but when you, because it's not a linear relationship, obviously, with the resistance resistance is not a linear thing. So that should, so even though these are 21 watts, when you join these in parallel and we get 17 ohms, we should be able to cope with 450. It should actually be spot on for 450 amps, 450 watts. So let us try that and see how we go. Okay, so I've cleared the pins. So the idea now is put a little bus bar across there. I think a bus bar would be nicer than just wiring, but for now maybe we'll just put some alligator clips there and get the reading. Okay, so now we've got our resistors lined up. What we can do is connect these in series, and we should get our, 16.8 I think volts. So if I so I'll just do this end, and we'll read off this end down here. 1 moment. Okay, easier said than done. So we've got this in series now. If I can manage it. Okay, so we've got our 2 8 ohm resistors. We're looking for 17. We've got the probes on, and if we look, we've got 16.5. I think that's pretty close. We might get around 500 watts of power across there. So my expectations are moderately high that we can get this to work. Okie dokie, there we've got our new resistor with some alligator clips on the end. We have the system under load. And I've got a spare thing here. It has just come on back on, and the relay got tripped pretty much straight away as soon as I added the load. So if we can see there's our charger. Well, that's with the charger on. Now this may not be good for the charger. We'll have to see. I'm about to put the load onto the thing. Can we see the current? Can't really see them both together with more fingers and thumbs, but if we put this on, we should get around, well, I've turned up the constant current, so we'll just hit the button, see what happens. And we suck the guts out of it straight away, but we should have got, yep, and we've dropped it below the cutoff voltage already. Okay, but we get the idea. We got 4.79 that time, I'm pretty sure. And just so you know, we were definitely getting 450 watts out of that, because those are untouchable, roasting hot.
So after like a few seconds of just melting. Well, they're not melting; they're actually designed for that. So yeah, but they are way hot. Yeah, so I'm still trying. It must be the other pot. So I have been turning this one here, and we haven't noticed any noticeable drop. But actually, I didn't measure the voltage across there. Yeah, we probably need to see the voltage drop to see if the whole thing's collapsing. I mean, the battery is being sucked to its guts out, and at 450 watts with a so we are drawing. So the initial current less than 2.7 amps, but I have seen the chart where this is quite happy to go to like 60 amps when you're drawing on it. So so we're not going anywhere near that. We're going maybe 40, but the guts are completely sucked out, so it drops below the voltage within seconds, and these get roasting hot within just a few seconds. So I definitely need to find out where the how to control that current, because well, that's just reading directly. So at 16 ohms, we were getting 4.7 amps. So 90 volts times 4.7. It's exactly what that's rated. So the booster is not limiting the load in any way, but we do want it to do that. Otherwise, it's just going to drop straight away. Just about we had the relay on there because we could have killed the battery. But yeah, so we can see the voltage drop this immediately. So we can see the voltage on here, but I'd really like to see it on the other side to see if it's staying at its 90. I doubt it would be, to be truthful. We can try it one more time, except we will need to alligator clip it. And man, that's going to be, well, these are still, even now they're still roasting hot. Oh, they're cooling off a fair bit, just while we've got it on the fireproof here. But anyway, I'll see if I can get that voltage reading and see if it's staying at 90. Then I'll try and adjust the other pot and see what happens. But also a word of warning, I let the probe go a bit early on here. It was a huge spark. So yes, there is we are talking serious power now. So 450 watts at 5 amps and 90 volts. That's definitely a dangerous kind of voltage. So I probably shouldn't be mucking around so much with this, especially just dropping the probe on the end. Okay, so but we can see in principle it's definitely drawing what we asked. The problem will be if the booster is not going to limit the current, then it's very likely that the inverter is going to ask for as much power as it will give, and I suspect it's going to exceed our tolerances. So we really do need the constant current to be working correctly. So what I want to do is, because we know this can go to 450, that's still hot. That is still hot. We know that's a significant voltage. What we want to do is, even we know this load, we want to drop it down. Can we do this? We want to drop down the constant current so that the booster doesn't deliver any more than a preset. So if we, given that this is definitely the voltage, looks like it's collapsing, we want to go far less current. So I'm trying to find, trying to get it to bring it back down to, let's try 2 amps and see if we can see what we get on that. Okay, guys. Now I really can't see a safe way to. So if I plug this in here, there's no way we'd be able to touch the end of that wire because that's kind of danger voltage. There'd be no way for me to shut this down. The relay would trip, of course, but you know, it might be
just a little bit too dangerous, I think. So we need a better rig, especially with a switch we can flip to make sure that we don't cause any damage to ourselves. Because we definitely wouldn't do that, but it definitely appears like we're dropping significant voltage. Certainly on the battery side, it's probably delivering decent current. Well, sorry, it is delivering a decent load, but that's exactly the amount that we'd expect from this resistor. So, and not in any way controlled. I may have to just check with the manufacturer and say, okay, which one of these is the constant current control, and can we actually specify the current that we want it to draw, regardless of the load on the other side. Okay, more investigation required. I'll catch up next time. Okay, so I've managed to find the right setting. So it is this pot that adjusts the constant current, this one here, and this one is for the low voltage cutoff, apparently. So having done my research now, and I've turned the voltage down to about 1.2 amps. So again, we've still got serious voltage here, so we do need to be, pay attention a little bit. So the plan will be, I'll just get the amp meter and the voltmeter together. Now I have checked, we are getting the right amount of voltage on the other side. So if we hit the button, we are now getting, if I can get my hand out the way, so we're drawing 1.2 amps. The voltage is still dropping. We're still trying to look for a spot that we can sustain the drain. So that's looking pretty solid. So we're sitting on 1.24, 12.4 and 1.2 amps. So I imagine that resistor is pretty hot by now. I don't want to touch it because it's very likely we're getting serious voltage through there. Okay, so we'll try and just make sure we're still reading 90.3 volts. That voltage sag is pretty serious still, though. So swap over to volts and just make sure we're still reading 9. No, we're expecting 90.3 volts. Again, my hand is exactly in the wrong spot. So on this side we've got 12.4. On the other side we should have 90.3 volts. And we do. So that's all looking solid. So we're drawing 12.5 and 90.3, and that appears to be stable. So I think that's about as much as we can draw out of this tiny battery. So again, just to give you those specs, we have this AGM 9 ampere hour battery where I have checked the charts, and the charts say that you should be able to draw a lot more power than that. However, at 4C, which is, we were actually exceeding 4C, I hadn't realised at the time, we were discharging at 4 times the rated voltage, so that would have given us about 6.5 minutes, according to the charts, at 4.7 amps or whatever it was. So and around the 400 amp, 400 watt mark. So that's our battery there. But again, this voltage sag, when we started to bring that kind of load on the battery, it was enough to trip the relay. So I think those are good numbers. We're currently on voltage. We'll switch back to amps and just make sure we're still solid, and watch that voltage sag as we go. Again, I'll try and get my hand out of the way so you can see both settings. Here we go, and we're getting 1.253 amps, and our voltage sag is not so bad. So we are dipping to 12.4, but that's what we were at before, and I think that's probably sustainable for the period until the battery drops below its current rating, its current low voltage cutoff. So we'll just see how much power we used. So we were at about 95% charge, and if we'll go off on the side. Don't really need that on anymore, and we'll put the charger back on because it has moderately sensible SOC, although yeah, because it hasn't charged, I doubt the number is really accurate. It probably, because it has no knowledge of how much current we just dragged out of it, although we'll be trying to estimate, I imagine, from the thing. So we used 25% of that battery's power in that just short period of time. So, but I think that's sustainable with this battery. So the next stage will be plug it into the Fronius, and all the rules say that should just work fine. That will be the next step. One more thing we might do just before we close off is we'll just check for heat. So the resistors are, I mean, they're reasonable. We're only pumping 100 watts on them, so it shouldn't be too hot. The relay was an issue before. It's warmish, but it feels like on the coil side, not the load side. So the load side is this side here, and the coils are on this side. So maybe we could get a small resistor. I think it can come down to about 7 volts. So we shouldn't need to dump that much power into the coil. So so what we might do is just put a small resistor on there, just to bring it down to maybe 7 or 8 volts, just to keep that waste. It feels warm, but the load side itself actually doesn't feel. The coil side feels hotter than the load side. So yeah, we'll definitely do that. Otherwise, I'm checking for other hotspots, terminals, ice cold, wires, all cold, bus bars, all cold. Have we discharged the remaining? I better just do that. So I don't want to touch the high voltage side while it's probably got anything in there. No, absolutely freezing cold. So all the loads and the wiring looks fine for that kind of load. We're only doing a quarter of what we'd planned, but again, this is just this battery just can't cope with what we'd planned. When we get the lithium iron phosphate, if it ever comes, we'll definitely ramp up that current there. So all we have to do is twiddle this pot here up a little bit higher, and set it to the correct current.
Okay, I hope you got something out of that. Just a spoiler alert. We did plug in, and we've been running for several months. We've got a couple of issues at the moment, but we have tried. We've got new batteries. We got some better housings for the device, a few other things, but I'll keep you up to date with new videos as we come. So I also do apologise for the recording at the beginning of this video. I had the lighting on the 60 Hertz setting. In Australia, of course, we have 50 Hertz, so we were getting some shut up issues there. But I'll catch up with you next time. Bye bye.